Today we're going to be taking a look at the quadratic formula. So we want to solve this by using the quadratic formula. But in order to use the quadratic formula, we need it in the form of ax squared plus bx plus c equal to 0. So we need that form. Now right now on the surface of this, we don't have that. We have 3x times x minus 1 plus 2 times x plus 2 equals 3. So I'm nowhere close to that form. The only route then is to just multiply everything out, see what happens, and see if we get into a favorable position where we can then use the quadratic formula. So let's go ahead and check. Or not check, I guess, but let's go ahead and figure this out. So 3x times x is 3x squared. 3x times negative 1 is negative 3x. Plus, and then I have this 2 times x and 2 times 2. So 2 times x is 2x. 2 times 2 is 4, equal to 3. Starting to take shape, right? It's starting to get there. We have the 3x squared, so we have this ax squared term. Now let's just start combining things, move things around. Let's see what happens. Negative 3x plus 2x. So I'll have 3x squared. Negative 3x plus 2x is negative 1x. Negative 3 plus 2 is negative 1. And then I also have this plus 4 equal to 3. So let's get this 3 over to this side. So then that way we start to get in that position that we want, that ax squared plus bx plus c. So I subtract 3. I'm going to get 4 minus 3 is 1 equal to 0. And look at that. Now I can use the quadratic formula where my a term is going to be 3, my b term is going to be negative 1, and my c term is going to be positive 1. The quadratic formula is negative b plus minus the square root of b squared minus 4ac all over 2a. I'm going to take this information then and just plug it into the quadratic formula. Negative b, so it's going to be the opposite of your b term. My b term is negative 1. Don't think of this as, oh, my quadratic formula is negative b, so therefore my b is negative 1, so it's going to be negative 1. Because it wants it to be negative. No, it wants the opposite of your b value. So if your b is negative, it's going to become a positive. If your b is positive, it's going to become a negative, and so on. And then plus minus square root of b squared, negative 1 squared, minus 4ac. So 4 times 3 times 1. All over 2 times my a term of 3. I think I'm getting pretty close to my camera here, so let me move this up. Now it's just simplifying some things out and breaking some things down. Let's see what happens. First, the opposite of negative 1 is positive 1. Plus and minus the square root. Negative 1 squared is negative 1 times negative 1, which is positive 1. Minus 4 times 3 times 1. 3 times 1 is 3. 3 times 4 is 12. Minus 12 over 6. Okay. See what's going to happen now. 1 plus and minus. On the inside of the radical, we have 1 minus 12, which is negative 11. This is over 6. Inside the radical, we have a negative. In this case, we have to pull out I. 1 plus minus I root 6 all over 6. And then from here, we have nowhere else to go. And the reason I pulled out a negative, or I'm sorry, the I, is because I have a negative inside the radical. So we pull out the I, imaginary number, and that's representing that negative because the square root of a negative 1 is equal to I. So if I have a square root of negative 11, that's really the square root of negative 1 times 11. Square root of negative 1 is I root 11. So that's where I'm getting, why did I write 6? This is 11. Must have been looking at the bottom. So that's how we get the I root 11. And then from here, I think we're good. I don't see any other potential routes that we can take. It's just going to be our solution of 1 plus minus I root 11 all over 6. And you could write this out as two different solutions if you want. So 1 plus I root 11 over 6, or 1 minus I root 11 over 6. Typically, we just leave it as this, though. You don't have to necessarily write it out as the two different solutions. But there it is. Yeah, so we have quite a fun problem there, I thought, because it's nowhere close to the quadratic formula form, like that form that we need. So we had to work it through a little bit, just first problem, half of the problem. And then we had to work it through, and then we had to use quadratic formula, and then we had to pull out I. So good problem there. So hopefully this was beneficial and helps you out with a problem like this.